Welcome back to the Dreamcraft Galaxy, where the boundaries of technology and the human spirit intersect. Imagine if machines could learn, adapt, and generate new content autonomously. What kind of a world would that be? Welcome to the realm of generative AI. In the vast universe of artificial intelligence, there's a fascinating subfield that has been capturing imaginations and revolutionizing industries. It's called generative AI. As the name suggests, it's all about generating something new, something original. But it's not just about creation. It's about learning patterns, absorbing information, and then producing output that is not only new, but also meaningful and relevant. Generative AI is like the ultimate artist, using data as its canvas and algorithms as its brushes. It has the potential to redefine creativity and innovation as we know it. From creating realistic images and videos that never existed before, to writing compelling stories and even composing original music, the possibilities are endless. But how does generative AI make this magic happen? Well, it's all thanks to some remarkable models that form the backbone of this technology. These models have been designed to understand, learn, and then generate. They are the secret ingredients that make the AI generative. First, we have the Generative Adversarial Networks, or GANs as they are commonly known. GANs are like the masters of forgery, capable of creating incredibly realistic images from scratch. Next up are the Variational Autoencoders, or VAEs. These are the experts at reimagining, taking existing data and adding their unique twist to create something new. Then we have the Recurrent Neural Networks, or RNNs. These are the storytellers, capable of understanding sequences and predicting what comes next. And finally, the transformer-based models like GPT-3 and GPT-4. These are the wordsmiths, capable of generating human-like text that can write essays, answer questions, and even write poetry. And let's not forget style transfer, a technique that can take the style of one image and apply it to another, creating a whole new piece of art. Intrigued yet? Each of these models has its unique capabilities and applications, which we'll be diving into in the upcoming scenes. So buckle up and get ready for a thrilling journey into the world of generative AI. Let's embark on this fascinating exploration of AI's generative capabilities. First on our list of generative AI models are Generative Adversarial Networks, or GANs for short. Now let's delve into the fascinating world of GANs. Picture two artists in a fierce competition, each trying to outdo the other. That's essentially what GANs are all about. GANs consist of two neural networks, the generator and the discriminator, both locked in an ongoing contest. The generator is the creative spirit, striving to produce convincing, novel outputs from random noise. It's like an artist, conjuring up new creations from a blank canvas. On the other side, we have the discriminator, the critical eye. It assesses the generator's outputs, trying to distinguish between real and fake. It's like an art critic, scrutinizing each piece to determine its authenticity. This dynamic duo works together in a remarkable way. The generator continually improves its creations, striving to fool the discriminator. In turn, the discriminator hones its skills to differentiate between real and generated outputs. This ceaseless contest leads to the generator creating incredibly realistic outputs. But where does the power of GANs come into play? Well, GANs have found applications in a myriad of fields. In the world of art, GANs have been used to create stunning pieces that have even been auctioned at prestigious galleries. They've also been used to restore and colorize old black and white photographs, bringing history to life in vibrant color. In gaming, GANs are changing the game literally. They're used to generate realistic environments and characters, enhancing the immersive experience for players. And let's not forget fashion. GANs are playing a pivotal role in the design process, helping to create unique and trend-setting designs and even predicting fashion trends. So, you see, GANs are not just two dueling networks. They are a powerful creative force, transforming industries and redefining what's possible with AI. GANs, with their dueling networks, represent an exciting development in the field of AI. They are a testament to the limitless potential of generative AI, and we're just scratching the surface of what they can do. Next, we delve into the world of Variational Autoencoders, or VAEs. This fascinating form of generative AI takes a unique approach, focusing not just on generating new outputs, but also on the way it handles input data. You see, VAEs are all about data compression. They take high-dimensional input data and compress it down into a lower dimensional space, a process known as encoding. But that's only half the story. Once the data is compressed, VAEs then generate new outputs from this compressed data, in a process known as decoding. This two-step process of encoding and decoding allows VAEs to learn complex patterns from data, all while keeping the data's size manageable. This is especially useful in fields where dealing with large amounts of data is the norm, like in image and video generation. VAEs offer a unique approach to generative AI, with an emphasis on data compression. Now let's turn our attention to recurrent neural networks, or RNNs. These fascinating models are an essential part of the AI family, especially when it comes to tasks that involve sequential data, such as language processing or music composition. RNNs are unique because they have a built-in memory of sorts. They remember prior inputs by maintaining hidden layers, a feature that sets them apart from other neural networks that treat each input independently. How does this work? Imagine each input as a link in a chain. In a regular neural network, each link is separate from the others, but in an RNN, each link is connected to the ones before and after it. This allows the network to pass information along the chain from one link to the next. Let's consider a practical example. Suppose you're writing a sentence, and after a few words, you pause. When you resume, you don't start a new sentence from scratch. Instead, you remember what you've already written and continue from there. This is essentially how an RNN works. It remembers the previous inputs and uses that information to influence the next output. This ability is particularly useful in tasks like predicting the next word in a sentence or the next note in a melody. For instance, in language processing, RNNs can analyze a series of words, remember the context, and predict what word might logically follow. Similarly, in music composition, RNNs can analyze a sequence of notes, recall the melody, and generate the next note that would fit within that melody. RNNs, however, are not without their challenges. They struggle with long sequences due to an issue called vanishing gradients, which hampers their ability to maintain long-term dependencies. But fear not. Scientists have developed variations of RNNs, such as long short-term memory, LSTM networks, to address this very problem. The ability of RNNs to retain information makes them an exciting part of the generative AI landscape. With continuous advancements and improvements, who knows what incredible feats these networks will achieve in the future? Let's now explore the transformative world of transformer-based models. Imagine a machine that not only understands human language but also constructs its own sentences. This isn't science fiction, it's a reality made possible by transformer-based models. These models, like the famed GPT-3, have revolutionized the field of natural language processing, which is all about teaching machines to understand, interpret, and generate human language. At the heart of these models lies the ability to understand context. They're not just matching words and phrases, they're comprehending the nuances of language and using this understanding to create human-like text. It's like having a conversation with a machine that truly understands you. But how do they do it? Transformer-based models employ something known as attention mechanisms. This technique allows the model to focus on different parts of the input when generating each word in the output. It's like the model is reading a book, keeping track of the plot and characters as it goes along, and then using this understanding to write the next chapter. The potential applications are limitless. From writing essays and articles to creating poetry and even scripting engaging dialogue for video games. The future of AI is exciting, and it's here now. Transformer-based models, such as GPT-3, are pushing the boundaries of what AI can generate. Finally, we arrive at style transfer, a visually stunning application of generative AI. Now let's take a moment to appreciate the artistry this technology brings to the table. Imagine you're an artist with a paintbrush. You've mastered the art of capturing reality in exquisite detail. Now imagine you've also mastered the abstract swirls of Van Gogh's Starry Night. The question is, can you blend these two distinct styles together? With style transfer, that's precisely what you can do. Style transfer is a technique in deep learning that blends the content of one image and the style of another to create unique AI-generated art. It's like having an AI Picasso in your pocket, ready to transform your photos into masterpieces at the touch of a button. The process begins by feeding the AI two images, a content image and a style image. The AI then analyzes the content image to understand the objects and their arrangement. Simultaneously, it studies the style image to grasp the artistic style. Once the AI has a grasp on both elements, it fuses them together, creating a brand new image that maintains the content of the original photo, but painted in the style of the second image. From turning everyday photos into impressionist paintings to creating modern digital art, style transfer opens up a world of creative possibilities. It's a tool that's not just for artists, but for anyone who appreciates the beauty of art. Style transfer showcases the aesthetic potential of generative AI. We've journeyed through the captivating world of generative AI, from GANs to style transfer. We've seen how these technologies are transforming the creative landscape. Generative adversarial networks, or GANs, are revolutionizing digital art, while variational autoencoders, VAEs for short, are making strides in anomaly detection and data generation. Recurrent neural networks, or RNNs, are pushing the boundaries in sequential data understanding, and transformer-based models like GPT-3 and GPT-4 are setting new standards in natural language processing. And let's not forget about style transfer, merging art and science to create unique visuals. These technologies have the potential to transform our world in ways we can't even imagine yet. They're not just tools for data scientists, they're tools for artists, writers, musicians, and innovators across all fields. They're reshaping our understanding of creativity and opening up new possibilities for expression. As we continue to explore and develop these technologies, who knows what amazing creations AI will generate next? We are here to help you. Stay abreast of this fast-paced, evolving field, but we need you to join us. We need you to be a part of this revolution. How can you do that? By subscribing to our channel, watching our videos, and sharing them with your friends and family. By sparking conversations around AI and becoming part of the dialogue? So, are you ready to be a part of this exciting journey? Are you prepared to witness the future of AI? If yes, then hit that subscribe button. Stay tuned, stay updated, and be part of this exciting journey. Subscribe to Dreamcraft Galaxy and never miss a beat in the AI revolution.